I think this is one of the more important lessons I do so you understand the difference between ionic and molecular compounds. I've given you guys this particular slide in your notes. It's online, check it out. What I want to do is take some time to go over this so everyone's on the same page. And not only that, but you can review it whenever you want to. All right, the first thing I'm going to look at is this particular relationship. It says the force of attraction of ionic compounds between ions is very strong, where the bonds between covalently bonded atoms within a molecule is the strongest. Well, let's look at that. All right, let me separate this. We'll call this side ionic and this side covalent. And the pictures I'm going to draw are actually very important. Now, when you have something that's ionic, let's take something we're very familiar with, which is the sodium chloride substance. Give me a second here to draw this. You'll notice that it repeats over and over again, and it goes off in many, many directions, actually 90 degrees from each other. So it's everything in the middle is bonded to itself. It bonds all the way on the outside. It just goes on and on forever. That's how I'm trying to draw this, okay? So when we talk about sodium chloride, we're actually talking about something called a formula unit. And because NaCl combination repeats over and over and over again, but never exists alone, we have to represent it as the lowest whole number ratio. We call that a formula unit. So the formula unit for sodium chloride, or any ionic compound, it's going to be the lowest whole number ratio of their substances. Okay, in this case, the sodium and the chloride ion combined. Okay, again, whoops, formula unit. Now, what happens here is if I were to take a lick of salt, I am actually going to only erase portions of it. You'll notice that I erased some sodiums and some chlorides, and I'm probably erasing them or licking them in a one-to-one relationship because that's what the formula unit tells me it is. Okay, so I erase some of those ions. Now, if we take a look at over here, a common covalent substance that you know of, which is sugar, C12H22O11. This is sucrose. And I have these molecules of sugar, and I have so many of these molecules that it actually forms a sugar cube. You'll notice that each one of these molecules exists as a separate entity, and it's associated, the 12 carbons, the 22 hydrogens, and the 11 oxygens are all together. Okay? They don't associate with any other molecules. As a matter of fact, the only way they are associated is one molecule is bonded to another in some type of framework, and it goes off in many directions to other molecules, and as you can see, in no particular pattern. This is the big fundamental difference. Ionic compounds consist of many parts that are repeating over and over again. Okay? Covalent looks like it's the same. However, if I were to take a lick of sugar, I cannot choose to take away a carbon or a hydrogen or maybe a couple oxygens because that's what I feel like I can do over here in ionic substances. The covalent substance, if I were to take a lick of sugar, I have to remove a whole molecule. I have to remove the whole molecule. I don't have a choice. Okay? So again, I cannot remove a couple carbons. I have to remove the whole C12, the whole H22, and the whole 11 together as an entity. So I see molecules existing as separate cohesive entities. Now, going back to the first point right here, what does that mean? It means this. The bonds inside of a molecule are the strongest. That's a number one. They're the strongest bonds, that chemical bonds that we know of. Okay? So the bonds within this molecule are quite strong. Second strongest are ionic bonds. Bonds between ions. Okay? Those are the second strongest. So what I would call bonds within a molecule or intramolecular bonds are the strongest, and ionic bonds are the second strongest. Okay, let's go back. Let's look at this second relationship here. It says the force of attraction between formula units is very strong versus the force of attraction between molecules is very weak. Well, let's see if we can set up another hierarchy. Okay, so I see that the force of attraction, let's review again, within a molecule are the strongest. Between ions is the second strongest. What that last slide or second point says, the bonds here, this number 2, is actually quite strong and is stronger than the bonds between molecules. Oopsie, let me put a 3 there. The bonds between molecules are the third strongest, and they're actually quite weak. Most molecular substances are not in the form of solids. I have tons and tons of ionic substances across the hall because the bonds between these ions are strong enough. Okay. However, the covalent solids across the hall, I probably have about 12 to 20 covalent solids because the bonds between these molecules are very, very, very weak. So therefore, covalent substances most often come in the liquid and the gas form. For example, water. There's covalent bonds or forces of attraction between water molecules, and the same thing, gases, oxygen you breathe, nitrogen you breathe, hydrogen's out there as well. Okay? All right, so again, bonds within a molecule are the strongest, bonds between ions, second strongest, bonds between molecules, third strongest. Let's go back. Okay, next one says, because the strength of attraction, ionic compounds are almost always solids. I just described that. Bonds between ions are so strong, they are almost always solids. But because bonds between molecular compounds are so weak, there are few of these, but we have a lot of liquids and gases. So I would remember that. Next, because these bonds are so strong between ions, we have tremendously high boiling points. How high? A lot of ionic compounds can boil at 1700 degrees Celsius. How low are these melting points in the covalent substances? For example, liquid nitrogen boils at, I think it's about minus 180 degrees Celsius, give or take 10. Okay, so I mean, that's really, really low. Now, based on that, whenever I dissolve ionic substances in water or I get them in the molten form, they will conduct an electric current. Okay, so they're electrical conductors when they're dissolved in water or when they're in the molten form, because they have charges, pluses and minuses. Molecules won't do that. They don't have charges. When I dissolve sugar in water, it will never conduct an electric current. If it does, then something went wrong. Ionic compounds almost always contain a metal. So if you see a metal, magnesium chloride, bang, you got an ionic substance. If you don't see a metal, then you're probably going to have a molecule. NH3, H2O, HF. Those are all molecular substances. I don't see any metals there. Okay? Take a look at this chart. It's a big deal, and it's very important to understand what's going on between ionic compounds and molecular compounds and how they differ. Lots of questions on the test on this. It's not good enough just to memorize this. You really need to understand what's going on here. Again, any issues, email me or ask me questions in class.